Welcome back, students. Today's video is going to focus on wave behaviors. We've already learned about a lot of different types of waves and some terminology that we can use to describe these waves. But now we can ask ourselves, how do these waves behave whenever they're moving in different situations? The first three terms I want to talk about are reflection, refraction, and diffraction. The first one I want to talk about is reflection, and this is the most intuitive one. Whenever you think of the word reflection, you think of looking at yourself in the mirror. That is what a reflection is. But reflection can also apply to other types of waves other than just light. A simple definition we can use for reflection could be waves bouncing off of a surface. In the case of someone looking at themselves in a mirror, this is a good example of a reflection because the light waves that are coming from whatever light source are there, maybe there's some lights on the ceiling. These light waves bounce off of a glass surface and they return back to the eyes of the person. You can also notice reflection in other instances of waves hitting surfaces. Whenever you see a water wave crash into a jetty or some rocks, you'll see them kind of bounce backwards. So once again, reflection is just waves bouncing off of something. The next term I want to talk about is called refraction. Refraction is a process that happens whenever waves go from one medium to another medium. So for example, when waves go from air to water, or from air to glass to water, or to any other medium, refraction occurs as those waves go from one medium to the next. Because these different mediums have different densities, the waves will be able to travel through them differently. Waves will travel slower in higher density mediums and faster in lower density mediums. So they will change speed as they go through the different mediums. And because of this change in speed, they also change directions. Okay, so a good definition for refraction would be that waves change speed and direction when passing through different mediums. A good example of this is whenever you have a clear glass of water, and if you put a straw in that water and look at it from the side, it'll look like the straw is bending through the water. But really it's just an illusion with a light due to refraction. We know that the straw is straight before you put it in, but whenever it goes through the water, the light is traveling through two different mediums, the air and the water. So it's going to change speed and change direction, which makes it look like it's bending. This could also change the way the size may appear. Here's a simple picture to kind of show that glass of water example with the straw. If you get a clear glass of water and put a straw in, it's going to look something like this. Alright, the next word I want to talk about is called diffraction. Diffraction is a process that occurs whenever waves are passing through an opening of a barrier. And what happens whenever waves pass through an opening of a barrier, the waves will start to bend around the corner of that barrier and start propagating from that barrier. It's easiest to show this in a picture. Okay, so here's my definition for diffraction. It is a process whenever waves bend and propagate through an opening of a barrier. And here's a good picture to show what that looks like. Like on the left side you have some waves moving toward the barrier. In that barrier there's a little slit, and whenever the waves hit that little slit, they start to propagate outward from that slit, and they bend around that slit. Okay, so here are three different wave behaviors that are important to understand. I'm going to erase these three to talk about one more different behavior called the Doppler Effect. The Doppler Effect is a phenomenon that occurs whenever a source of waves is moving in relation to an observer. So maybe there's someone on the sidewalk who's listening to music coming from someone's car who is moving. In that case, the observer is the person standing on the sidewalk, and the source of the waves is the car with the speakers playing. Because the source of those waves is moving at some velocity, the frequency of the waves that are perceived by an observer, like someone on the sidewalk, is going to be skewed based on the fact that if the source of waves is moving away from the observer, then the waves that are hitting the observer have larger wavelengths or lower frequencies, whereas whenever the source of waves is approaching the observer, those waves have shorter wavelengths or a larger frequency. This is why whenever you hear like an ambulance or a siren come towards you, it gets higher pitch, and then as it leaves you, it gets lower pitch. I've written out my definition for the Doppler effect. The Doppler effect is a change in frequency of waves as the source moves towards or away from an observer. And I've drawn a little picture here of like my car example, where if it's moving forward, the waves that are coming out from it on the front side of the vehicle are going to be more crunched together, whereas the waves coming from the back side as it moves away will be more spread apart. So if there was an observer right here, and if this car approached this observer, then he would hear whatever sounds are coming out of the car at a higher pitch than what it actually is. And then as it passes by, the observer would be over here, Then he would hear that same music at a lower frequency, so the pitch would go down. Because the person inside the vehicle is moving at the same speed as the car, they're not going to experience the Doppler effect at all. They're just going to listen to their music at the regular pitch. Alright, the last thing I want to talk about is what happens whenever two waves collide with each other. Whenever two waves collide with each other, we say that they interfere with each other. And there's two types of interference that can happen with waves: constructive interference and destructive interference. So whenever two waves interfere with each other, their wave patterns are said to be added together. If this pulse moves to the right and this pulse moves to the left, then when they collide with each other, they will interfere and their wave patterns will add to each other. Because they are both in the part of their cycle that is above the equilibrium line, whenever these wave patterns add to each other, they constructively interfere, which looks like this. So if you add this wave pattern on top of this pattern, it'll just be a bigger wave at the point where they converge. And this is called constructive interference. So they add to each other, they make each other a stronger, bigger wave. Okay, so simply put, constructive interference is whenever waves collide and make a bigger wave. The opposite of constructive interference is destructive interference. So destructive interference would be whenever waves collide and they make a smaller wave or cancel each other out. In this case, they're on the opposite part of the cycle, where one is on the top and one's on the bottom. So whenever they collide with each other and you add their wave patterns together, then they cancel out. Okay, so after these two waves collide, it would just be a flat line, and these are the same size. Okay, so in this video we talked about reflection, refraction, diffraction, the Doppler effect, and then constructive and destructive interference. That's all for today's video. Thank you, hope to see you next time.